Hey there YouTube, Nicholas from Game Dev Maniacs here. This is the third episode in the beginner series where we learn how to make a simple 2D action game from scratch called Showdown. And today we're going to be doing a deep dive into programming and learn our very first important concept. But before we get into that, I realized that we made a tiny mistake in our last video. So let's go ahead and correct that now. In our last video, we used the instruction map, and we wanted to draw the entire map starting at cell 00 into our screen starting at position 00. However, when we run the game, we can see that what we're drawing isn't exactly positioned at the very top of the screen. So something is wrong here. What we can find is if we look at our map editor, what seems to be at the very top might actually not be at the very top. And the way that you can see that is if I zoom out using the mouse wheel, you can see that there is an actual row of empty cells at the very top. And at the very bottom, you can see the coordinates for the cell that we're selecting. Right now, it's 3, 0 for X and Y. If I go all the way to the left, this is the cell 0, 0 at which we're starting to draw. So actually, we're drawing the entire map starting with this cell here. Now there's two ways to fix this. One way would be to say, well, let's start drawing the map starting at this cell, which is at coordinate 0, 1. We can actually try that right away. Let's go back to our code editor, and instead of saying print the map starting at cell 0, 0, we're going to say print the map starting at cell 0, 1. Let's save the game and run it. And you can now see that the map is currently printed all the way at the top. However, this is not ideal because if we go back to the map editor, we now have this full row of information that we're not using, that we're probably never going to be using. So probably a better way is to actually move this section of the map one cell up to the very top portion here. An easy way to do this is by using the select tool and simply dragging and dropping all the way across the map that we want to select. We'll then be using the Control X or Command X command to cut this into the clipboard. And similarly to the sprite editor, we can then use the stamp tool to stamp it wherever we want it. In this case, we're going to put it all the way at the top left. Now that this is done, we will want to use the map command starting at cell 00. So I will go back in the code here and remove this one and replace it with a 0. Let's go ahead and save and run our game. We'll see a similar result, but the main difference is now we'll be using our map properly. So Pico 8 uses a programming language called Lua. Lua is a very simple language that makes code very easy to read and easy to write. As a result, you may think that it may not actually be used to create real video games. But in fact, Lua is one of the most beloved languages in video game development. It's actually used all over the place. Most games use Lua to code the gameplay logic. So today we're going to be talking about one of the most important and fundamental notion in programming. This is variables. We're going to go back and forth constantly between this slide deck and our code in Pico 8. In every single game out there is data or pieces of information that just evolves over time. For example, this is a screenshot of the original Super Mario on the NES. Can you think of some information that's displayed on the screen that would evolve over time? Well, for once, the current score is something that should keep going up as Mario battles through the level. The number of coins should also increase as Mario picks them up. And of course, this time should decrease naturally. We could even go further. The star on the screen is a moving object that has a sprite, and the position of that sprite evolves over time. So does Mario's position and the sprite image that is used to represent him. Each of the fireballs is a moving object that evolves over time. And then you also have the two Goomba brothers, who were probably having a good time chilling under the sun until Mario came along. So the screen is filled with information that just keeps evolving over time. And in order for the computer to process this, it has to neatly store and retrieve every piece of data in its memory. It's organized a little bit like storage compartments, and each of those compartments is what we call variables. Think of it like a garage that is well organized with neatly packed boxes. Each box represents a variable in memory. The same way that you could have a label on each box to make it easier to locate it, variables also can have a unique name. Each box in the garage can have some stuff in it, and similarly, variables also contain values that can evolve over time. As the game runs, the computer constantly looks for those boxes, figures out what's inside, and then either changes it or uses it for the game, such as displaying it on the screen. The way that we create and fill up a new variable is by writing what we call an assignment instruction. It goes like this: name equal value. In this example, we're defining 3 variables: score, coins, and time, according to the screenshot. And we're assigning various values to them. The coins will have the value of 5, the score will have the value of 40 to 50, and the time will have the value of 283. Names of variables should typically start with a letter and shouldn't contain any special character, like a space, for example, within them. Ideally, they're fairly short, concise, and descriptive enough that as you see them on your code, you know exactly what they refer to. We can use our variables inside our code by simply referencing them in our instructions. When the computer tries to execute this instruction, it will first look for a variable or a compartment entitled coins. If it cannot find it, it will throw an error and the program will exit. If it is able to find it, it's going to open up the box or container and figure out its value. And then within the instruction, it will replace the variable by that value within the instruction in order to execute it. Let's take this code for example. The first line, coins equal 5, creates a new variable and assigns the value 5 into it. When the computer gets to the second instruction, it realizes that we're looking for a variable called coins. So it will look amongst all of the variables in its memory, find a variable called coins, the ones that we just created, and look at its content. In this case, the content will be the value 5. It will then replace this variable by the content 5 and continue to proceed with executing the instruction. In this case, it will multiply 5 with 10 for a value of 50 and print out that value in the command line. In this specific code example, we're redefining the value of coins. First, we create this new variable and assign it a value of 5. But the next instruction down redefines the value and gives it a value of 6. The program will use the same variable and just simply change its value from 5 to 6. Similarly, if you had a box in your garage with a specific label, this would be equivalent to emptying it out and replacing it with a different content, but we would still keep the same box. In the third line, we're defining a new variable called score and assigning a value of coins times 10. In this case, the computer will look for a storage box called coins that is the same one that it had redefined earlier, look at its current value, which is 6, and multiply it by 10. This means that when we print the content of this variable called score, it will come back with a value of 60. We can reuse a variable name and re-reference it even when we define the value of its own name. For example, here, score equals score plus 1. The computer will go and try to find a compartment or variable called score and figure out its current value. Because it has been defined in the past, it will simply replace this variable with the value 60 and complete the instruction by adding 1. the result being 61. That value of 61 will then be assigned as a value of this variable called score. So the computer here in this instruction does two lookups for this box called score. The first lookup so that it can replace the value, and the second lookup so that it can assign this newly calculated value to the variable score. Inside Pico 8, it is actually possible to run those code instructions directly inside the terminal and not necessarily have to go through the code editor. Here we are in the terminal and we just ran our program. It would be nice to clear the screen. And as we learned earlier, we can simply do that using the instruction CLS, open parenthesis and close parenthesis, to clear the screen. Let's go ahead and use some of the instructions that we had previously done. For example, I am going to create a variable called score and assign a value of 50. I can now print the content of this variable. Let's go ahead and add 1 to this previous value and print its current value. One of the nice things about additions and subtractions is that you can actually use a shorthand form to do this. One way that is equivalent to the instruction above is by typing score plus equals 1. This is equivalent to saying score equals score plus 1. The computer will know that we're trying to refer to the same variable as the one that we're trying to update. If I now print the score, it will now come back with a score of 52. There are 4 types of variables in the language Lua. The first type of variable is called string, or string of characters. This is equivalent to a piece of text. The way that you create a string variable is by putting double quotes in between the text characters that you want to use. In this case, we're defining a variable called name, and we're assigning the value a string of character that says hello Mario. The second type of variable is a number type. We've been playing with this already, but numbers can be either positive, negative, or decimal. The third type of variable in Lua is called booleans. These variables can only have a value of true or false, and they're used extensively when doing logical operations. The fourth type of variable is a table. And think of a table as a list of elements or a set of data that can be used. Tables can contain tables as well, so this can be quite complicated. A couple of useful ideas about each type. First, regarding strings of characters, we can receive the length of a string by using the hashtag character. In this code example, we are defining a variable called name and assigning it the value Mario as a string. If we print hashtag name, we will then see the results 5 because there are 5 characters in the string of text Mario. We can concatenate or join strings with 2 periods. In the code below, we create a variable called name and assign it a value of Mario. In the line below that, we want to print another variable. This time it is the string hello with a space, 2 periods to concatenate with another string, which is the name which we had just created before. The result of that instruction is simply hello space Mario. Time for a little challenge and for you to try this out. Here's an exercise for you to try. After storing your first name and last name in 2 separate variables, can you figure out how to write the command to print out your full name in blue on the screen? As a hint, you can use an alternative to the print instruction, which is print text, color, color being a new argument, to print your text in a specific color. Go ahead and pause the video now and see if you can figure this out. Hopefully you had a chance to try this out for yourself. Here is the solution to this first challenge. we want to create two variables, one for the first name and one for the last name. Let's go ahead and do that now. We're going to create our first variable, give it the name first, and we're going to give it a value of Bruce. Let's create a second variable called last, and we are going to assign the value Wayne. If we were to print first period last, the result will be Bruce Wayne all attached. While this almost solves the problem, we're still missing a space character. And the space character is pretty much a string that only contains a space character. So one easy way to do this is we could print our first period, use that string as a single space character, period to concatenate again with our last name, and hit enter. We now have a proper displayed name. Now, while this works in practice, you may down the line want to have a quick reference to the full name. So it may actually be better to create a third variable called full name, or we'll just use full, and we will simply enter exactly what we just printed before, which is first period concatenate with an empty string and concatenate with last. We've just created a new variable and assigned the value of our full name with a space in the middle. We can now print this simply by referring back to it within our instruction. Now the challenge wanted us to color this in blue and gave the hint that we should use an alternative to the print instruction. One of the ways that we can find the color is by pressing escape and hopping into our sprite editor. As we hover over the colors here, you can see at the very bottom the color code for each color. Black being color 0, yellow being color 10, and blue being color 12. We're going to press escape again to go back to the terminal, and this time we're going to print our full name and use the second argument, 12, to color the output in blue. This is the solution to the first challenge. I hope you were able to get it. Here's some useful information on the number type. Sometimes you may want to do some math inside your variable. The order of operations matter. In Lua, multiplications and divisions take precedence over additions and subtractions. In the code instruction below, the multiplications 5 times 10 and 3 times 3 will be computed before the additions. In this case, the computer will read 2 plus 50 minus 9 minus 1, and the result will be 42. If you wanted to alter the order of operations, you could use parentheses to force the computer to first do computation under the parentheses before executing them with the operators. Another useful tip for using numbers is that from time to time, you may actually need to print those numbers onto the screen next to some text. And the only way you can actually concatenate a number with a text is to make that number a string first and foremost. For that, Lua provides a useful instruction to convert a number into a string. That instruction is tostr, which stands for toString. In the code snippet below, we create a new variable called text and assign a value of lives that we concatenate with what is executed by the instruction tostr5. toStr5 will actually return a string with a single character, which is the character 5. It will be concatenated with lives, which means that when we print out the text, we will see lives, comma, 5. Let's try another challenge. Can you figure out how to swap the value of two variables using simply a third variable? This is very handy when you need to swap the values of two variables between each other. Pause the video now, create two variables, and try to figure out a way to swap the values of those two variables. At this point, we already have two variables, first and last, and we would like to swap the values of both in a way that if we print the first variable, the result should be Wayne and not Bruce. What happens if I simply give the value of the first into the value of the second? If I put first equals last, then I can go ahead and print my first name, which is Wayne. But the problem is if I print my last name, it will also be Wayne. So there's no way for me to get back to this first value of Bruce. It's lost. I only have two variables, and both of those variables have the same value, which is Wayne. So there's no way for me to put Bruce as a value into the variable called last. The way that you can swap the contents of two variables is by using a third temporary variable. Think of it as, again, thinking about your garage. If you had two full containers that are full of things that you want to swap between those two boxes, you can use a third empty box and put the contents of one into another as temporary storage, so that you can swap the contents between the two storage boxes. Let's use this in the code. We'll go ahead and redefine our first name as Bruce, and we'll go ahead and redefine our last name as Wayne. We will create a third temporary variable. Maybe we'll use a variable called temp to indicate that it's not meant to last for a long time. And this one, I am going to assign the value of the last variable. Actually, let's do the first variable. This means that when I change the value of the first variable to being the one of the last name, and I now have the same content for my first variable than for my last variable, luckily, I have saved the content of the original first variable into my temporary variable. And so the only thing I need to do now is to simply use the content of that temporary box and put it inside the content of my last variable. So after doing these instructions, I will now have swapped my first name and my last name. This is an easy way by which you can swap the values of two variables using simply a third variable. I hope that you're able to find the solution to this. Another interesting note on tables. Similarly to the length of a string, you can also get the length of a table by using the hashtag operator. Here we're defining a table called days, which contains the data Monday, Tuesday, and Wednesday, which are simply 3 strings. And we want to print out the size of this list. We can use that using the hashtag character. In this case, the instruction print hashtag days will return 3, as there are 3 elements inside the set. The nth element of a table can also be retrieved using brackets. As we redefine in the snippet below the same list, the same table, days equals Monday, Tuesday, and Wednesday, we can retrieve the second element of the table simply by providing days and then 2 under brackets. This will return the text Tuesday, as it is the second element inside our table. It's important to note that in Lua, table counting starts at 1 and not at 0, like in other languages. Here's a third challenge tied to tables and end lists. Can you figure out, independently of a table size, how to print the last element of a table? For example, if I have a table that contains 4 elements, what would be the instruction to print out the 4th element of that table? The instruction should be the same regardless of the size of the table. Let's pause the video now and try to figure out the solution to this problem. Here's the solution of this third challenge. Let's go ahead and create a table. Let's call it list and give it a couple of random numbers. Maybe we'll give it some multiplies of 5. We know that we can figure out the length or the size of the list by using the hashtag character. For example, here, the list has 4 elements, hence we're returning 4. We also know that we can retrieve the first or second or third element using brackets and then indicating which element we're interested in. For example, here we want to retrieve the second element, which is the number 10. So how do we retrieve the last element? Well, one quick way to do this is by simply putting into brackets the size of the list. This means that we are first going to compute the size of the list, which is 4, and the second instruction will be to retrieve the fourth element of the list. This is returning 20, which is the last element of the list. This works independently of the size of the list. For example, if I redefine the list as an item that contains 5, 6, let's do 1, 2, 3, 4, 5, 6 elements, and I'm going to execute the same command as we did before. It will print now the number 9 as the last element. I'm realizing now that the last element is the same as the first one, but trust me, this is working. I hope you're able to figure out the solution to this. So you may be wondering how we could be using this in our game. One simple example relates to the positioning of our characters. We know that we want to have two cowboys face off each other. And ideally, those cowboys are positioned in a somewhat symmetrical way on our screen. So first, let's go ahead and draw those two characters in our sprite editor and try to position them manually on the screen. For that, we're going to press Escape, and we're going to hop into our sprite editor if we're not there already. Just like we did for the background sprites, we're going to go ahead and start by taking an empty sprite here. And we will start by drawing our character just by using random pixels. I will start with the head here, and let me actually position it a little bit more towards the center. And let's go ahead and give it some sleeves and a shirt, and we will also give it some pants. Of course, since it's a cowboy who's going to be shooting, we're going to give this guy a gun. And this is just about it. Oh, I guess it's a cowboy, so let's go ahead and add a hat here. All right, this is good enough. Now let's draw our second sprite. This is going to be the same cowboy, maybe with different colors, just facing the other way. There's a quick trick here that we could use, which is to flip the sprite. We're going to copy and paste the content of this image into the next sprite. Let's go ahead and use the select tool, select all of our sprites, and use Control-C or Command-C to copy the contents into the clipboard. We can now go to a blank sprite. We'll take the one right next door and use the stamp tool to just paste it in place. So here's the exact same image as the one we had previously drawn. I'm going to go back to the draw tool here. What we can do is press the F key on your keyboard. What this will do is it will flip the sprite. You can do that as often as you want. This is very handy if you want to reuse the same sprite, but maybe in a different configuration. In order to distinguish this little guy from its opponent, we'll probably give it a little bit of a different colors. Perhaps we will give this guy some fashion hot pink pants and a purple shirt. There we go. Let's now go back to our code, and we're going to try to place those characters manually on the screen. For that, we will go to the code editor and we will go to a new line. We now know that in order to print a sprite on the screen, we need to use the sprite command, SPR. The first argument to this is the number of the sprite. For that, we can go to the sprite editor, go in the sprite that we want to display, and look at the number that is associated with this sprite. In this case, this is number 17. Let's go back to our code and type 17 here. First, we'll give it some random location, and we will have to fine-tune it with our hands in order to better position the character. Perhaps we'll place it at 20 pixels on the left and 20 pixels on the top. Let's go ahead and save, Control-S, and run with Control-R. Okay, well, this is a floating character. We need to bring it down a little bit so the vertical position is not correct. There is a better way to find the vertical position than to just play around with the number and just change it to see if it's accurate. This is by using the map editor. Let's go ahead and zoom in here and also use the draw tool. We'll actually pan a little bit so that we can go back to a full screen here and have a better view. So if we were to draw our character on the map, we could simply click here and it would be drawn inside the background. It's not necessarily what we want to do, but what is interesting here is that we can see the location of where we'd want the character to be. If we look at the bottom of the screen, we can see that the cell location inside the map has a coordinate of x3 and y5. Each cell being 8 pixels tall and 8 pixels wide, this gives us the proper positioning of the sprite in our code. Y being 5 vertically and each cell being 8 pixels, if we multiply 5 by 8, we get the proper position, vertical position of the sprite. 5 by 8 is 40. I'm going to go back to the code and replace my vertical position here with 40. Let's go ahead and save and run our game. Now our sprite is properly positioned. Let's go ahead and place the second sprite. We'll type SPR. It is the next sprite over, meaning it is sprite number 18. And let's go ahead and place it somewhere towards the right-hand side. Perhaps we'll give it a location of 70 for the X coordinate, and it should be at the same position vertically. So we'll give it a value of 40. Save and run, and there's our character. So as you can see, both characters are now on the screen, but they're not really ideally positioned for the game. This is a place where we can use variables to play around with better positioning. And this is what it looks like. In order to position the two characters in a symmetrical way, one from another, we could define the distance from the sprites to the borders of the screen. Here we call that the margin. When we call the sprite command, we're looking for the coordinates of the two blue pixels located on the schema above. Those we are giving the variable name p1x and p2x. And using variables, we can use simple math to determine the values of p1x and p2x. For example, if the margin is 10 pixels, p1x is equal to that margin, and p2x is the total length of the screen, which is 128 pixels, minus the size of the sprite, which is 8 pixels, minus the margin. By doing this, if we increase the margin, both characters will get closer to each other, still symmetrical to the center of the screen and to the borders of the screen. As we reduce the margins, both characters will be closer to the screen. Let's see that in our code. Let's go ahead above the map before placing the sprites, and we will define a new variable called margin. For now, we will give it a value of 10 for 10 pixels. We said that the new variable called p1x would be equal to that margin. And the value of the second location, p2x, would equal to 128, the length of the entire screen, minus 8, which is the length and width of the sprite, minus margin. We can now use those variables p1x and p2x to properly position the sprites. Here, we want to change the horizontal position and replace this with p1x. Here, we also want to do the same thing, but replace the content with p2x. Let's go ahead and save and run our game. As you can see, both characters are now symmetrical to the screen. They're a little bit tied in their own cactuses, so let's go ahead and bring them closer together. Let's press escape again, and let's just change the amount of margin. If we increase this to, let's say, 40, save and run the game, you can see that the two characters are once again well positioned on the screen and closer together. This allows you to simply modify one parameter and figure out what fits best for your game. That is the real power of variables. We're now coming up to our last challenge, and this will be the last challenge for this lesson. What we want to do for our game is center the title of our game into our screen horizontally. Can you figure out how to do this and print it somewhere in red so that it is centered horizontally on our screen. I'll give you two hints to execute this. The first hint is that every character that gets printed on the screen takes 4 pixels. The second hint is that there is a third alternative to how to use the print instruction, which is that we can pass the X and Y coordinates as arguments for the text to be printed at that location in a specific color. Go ahead and pause the video and try to see if you can figure out how to print our game title in red, centered horizontally on the screen. Alright, so in order to understand the solution to this problem, we are going to be using a small sketchpad. So let me go ahead and draw the two axes here. We'll draw the horizontal axis and we will draw the vertical axis. We know that we want our title somewhere in the middle. I will position it roughly here in the middle. So what we're looking for with the print command is the top left position of our title, basically this pixel here. This is the coordinate that we want to pass to our print command. And we can use variables to find the location of this coordinate. There's a few things that we know. First of all, we know that the total length of our screen, the size of our screen, is 128 pixels. So if we wanted to see the middle of the screen here, we know that this distance is equal to 64 pixels. Something else that we know is that each character in the screen takes 4 pixels. And so we can figure out the actual width of the entire title by saying that this is 4 pixels multiplied by the number of characters in the string. And if you remember in the lesson, we learned that there is a handy way using the hashtag character to figure out the size of a string. So here, if we were to do 4 pixels times hashtag title, title being the name of the variable, we would actually get the entire size of our title in width. We're not actually interested in the entire size, we just want to know half of that size. Let's say that for convenience we call a variable L, which contains this value. This means that what we're looking at here between the pixel that we're looking for and the middle is L divided by 2. And so the solution to the problem, what we're looking for, which is this distance here, the X coordinate, is simply 64 minus L divided by 2. Let's go ahead and see how it behaves in the code. Let me go to the bottom of the screen, and we are going to create a variable called title, and we will give it the value showdown. We will then figure out the length of this title. L equals the size of the string title multiplied by 4. We know now that we want to position the screen and our title at position L divided by, 64 minus L divided by 2. And we will give it a vertical position of, let's say, 20. And we want to put that in a red color. So once again, I'm going to go to the sprite editor, hover over the red color, which is 8, and go back to our code and type 8. Close the parentheses, save, and run. And there's our title, perfectly centered on the screen. And so once again, the advantage of using these variables is that I can just update a single place. Let's say that our game does so well that it forces us to create a sequel. I will now have a title that's a little bit longer. And if I save and run the game, the title, even though it's longer, is perfectly centered on the screen. This is it for this lesson on variables, and I hope that it was really useful. This is one of the most important concepts in programming, so if you haven't fully understood everything, I'd strongly encourage you to watch this lesson again.